Okay, so this is the second quarter progress check review for Honors Algebra 2. The first page, you get this formula sheet, so use it if you feel necessary. The progress check does go back to exponentials and logs, so let's start with some exponentials. Simplify the following expressions. When the bases are multiplied, we can add the exponent. So x plus 3x is 4x, and 1 plus negative 4 is negative 3. When the bases are divided, we can subtract exponents. And you just have to be careful with the subtraction to distribute the negative. So this becomes 2 to the negative 2x plus 5. When you have an exponent to an exponent, we multiply. So that's 2 to the 12th. Now in D, the bases are not the same, but I can get them the same. And I'm sorry the video keeps shaking. I'm on a wobbly table and I'm not going to stop because then I'd have to start over. So, sorry. So for D, I'm going to make 4 2 squared, but now we have an exponent to an exponent. So that is really 2 to the 2x plus 4. We multiply the exponents. Now I can add exponents to get my final answer. Same thing in E. I'm going to make the 8 a base of 2. And then I can multiply the exponents in the denominator. Excuse me. And then I'm going to subtract. So 5x minus 3x, negative 1 minus 6, and that is my final answer for E. And then for F, I'm going to make 9 3 squared. So when I multiply those exponents in the numerator, we get 3 to the 2x squared. So condensing that and subtracting, I'm going to get 2x squared minus 2x minus 1, because you subtract the entire denominator exponent. All right, so for number 2 with the logarithms, you do get a calculator on the entire test, so if you want to use your calculator, go for it. I like to think of them as exponentials. So for this, we're going to say 3 to what power is 9? That's 2. 4 to what power is 1/16? And then just like in number 1, I'm going to make the exponents, the bases the same. So 16 is 4 squared, but to move it out of the denominator, I make the exponent negative. This one is 10, so 10 to what power is 10,000 is 3. E to what power is e to the first is 1. For E, 6 to what power is 1? Well, anything to the 0. In F, e to what power is 1 over e? So this e has an exponent of 1. So I'm going to move the term out of the denominator by making the exponent negative. 4 to what power is 8? So I'm going to make them both a base of 2. So 2w equals 3, and I get 3 divided by 2, or 1.5. And then lastly, 100 to what power is 10? So 100 is 10 squared. So 2w equals 1, so I get 1/2. Match the log with the left with the approximate value on the right. All right, well, let's start with B. 3 to what power is 10? Well, I know 3 squared is 9, and 3 to the third is 27. So that's between 2 and 3, so this one is B. I'm going to rewrite this. All right, first, let's do A. So 2 to the x is 18. So 2 to what power is close to 18? Oh, 2 to the fourth is 16. So, and then 18 is more than that, so this one must be A. And then for C, 10 to what power is 20? Well, 10 to the first is 10, and 10 squared is 100. So that is between 1 and 2, so that's C. And then D, if I have the 1/5 to the x equals 1/6, well, I think that's also between 1 and 2, because if I do 1/5 to the first, it's 1/5, and 1/5 squared is 1/25. But where's 1/6? Oh no, 1/6, here in case you don't like visualizing fractions, 1/5 is 0.2 and 1/6 is 0.1, so it's smaller. So that is why it's between 0 and 1. Because if I do 1/5 to the 0, that is 1. And 1/6 is between 1 and 1/5. It's in here. Okay. D, oh, sorry, number 4. Choose the approximate number for the, oh, we got a number bank, sweet. All right, so this is saying 2 to what power is 1/2? That's -1, because this has an exponent of 1 to move it out of the denominator. Then the next one is e to what power is 1? That's 0. This next one, 10 to what power? No, 10 to the third is the box. That's 1,000. This one's the base to the first is 10. Well, that's 10. This is 2 to the 5th is our box. That's 32. And this is saying e to the first is the box. Well, that's just e. Solving. Exact or decimal? All right, well, first we have to isolate the exponential. You get a calculator on your entire test, so let's use it for the arithmetic for time's sake. So then I'm going to change this to a logarithm. So log base 10 of 550 is x. If you want to type that in your calculator, the log button is a base 10. The log button is over here by the 7. So 3 places beyond the decimal point is 2.740. For B, I'm going to change this to a logarithm and then divide by 2. So the ln of 142 all over 2 is t. And if you want to get the decimal, the ln button is right underneath the log button. 2.478. For C, we have to isolate the exponential, so I'm going to subtract 100 to the left. Sorry, I know that's really shaky, I'm sorry. Divide by 5. Change it to a log. And divide by -2. So as a decimal, -1.498. All right, number 6. Write the function rule. So 1 unit to the right is going to be x minus 1 in the exponent. It's a big minus. The asymptote is at y equals -4. So normally the asymptote's at 0, so this is a down 4 transformation. Reflected across the x-axis makes a coefficient negative. Across the y-axis makes the x negative. Oh, we got multiple transformations here in E. All right. Up 4, right 5, and reflected over the x-axis. So reflected, right 5, up 4. Let's do the same thing with the log. 2 units left, so log base 2 of x plus 2. You need those parentheses to show that the plus 2 is with the argument. If the asymptote is at 2, well, normally it was at 0, so this is right 2. So that's an argument of x minus 2. Reflected across the x-axis. If you want parentheses, you can still put them around the x. And up 4, oh, same, right 5, and reflected. So reflected, right 5, and up 4. Jack decides to solve the equation. Solve it and determine if any solutions are extraneous. Okay, so I'm going to square both sides. So then the right is x plus 1 times x plus 1. So you have to multiply those together. I'm going to move everything to the right side so that I can factor to solve. Oops. Sorry. So then x squared minus 4, I can factor to the conjugates of x minus 2, x plus 2. And I get x is negative 2 and x is positive 2. But we have to check them. So I have to go back to the very original equation and see if they make a true statement. So this is the square root of 1 equals negative 1. That is not true. So that is not a solution. Negative 2 is extraneous. If I plug in 2, so that's the square root of 9 equals 3. That is correct. So 2 is the only solution. Okay, we get to do that 2 more times in 9. So x minus 5 squared is x minus 5 times x minus 5. So that's x squared minus 10x plus 25. I'm going to move everything to the left so that I can factor. So what multiplies to 24, that adds to negative 11. It's going to be negative 3 and negative 8. So set each factor equal to 0. And check them. 3 minus 5 equals the square root of 3 plus 1. No. Yes. Square both sides here. N minus 7 times n minus 7 gets me that trinomial. And we're going to factor. So n is 10, n is 7, and when I check, let's see, square root of 30 minus 21 equals 10 minus 7. That is correct. And that is correct. So B has 2 solutions. Oh no, I hope you could see that. Sorry, I didn't pay attention if that was on camera. When I check the 10, that solution works, and when I check the 7, that solution works. Identify the degree, zeros, and behavior for the following functions. Okay, so if I look at A, the multiplicities are gonna add up to a degree of 5. The zeros are negative 1 and 2, so that's when each factor equals 0. So the end behavior, because it's an odd degree and positive leading coefficient, is like a line. So as x goes to infinity, f of x goes to infinity to the right, and as x goes to negative infinity, f of x goes to negative infinity to the left. Now for b, the degree is 6. If I add up the multiplicities, 2 plus 3 plus 1. The zeros are negative 2, 4, and negative 6. And I have a negative leading coefficient with an even degree. So I think about a parabola, because that has an even degree that's been reflected. So as x goes to infinity, g of x goes to negative infinity. And as x goes to negative infinity, g of x goes to negative infinity. All right, 11 requires the calculator. Please pay attention on your test to rounding. So we have an x to the 4th minus 4x to the 3rd plus 8x. Oh, wait, I gotta set my window. Zoom 6. If your window is not nice on your test, if you hit zoom 6, it'll change it to a nice window. Ooh, this is my favorite kind of graph. It's a W for Weiss. Let me sketch it. And I like to label all the points, and then I will fill in all my information. So I'm gonna hit second trace. Let's do all the x-intercepts. So 0. I'm gonna find this one over here. So I'm gonna go left bound, enter, right bound, enter, guess, enter. And that is at 3 decimal places, negative 1.236. Second trace zeros. Find the other, oops, I have to hit the right arrow. 3 of them. It's a lot of button pushing. So this one's at 0. Enter, enter, enter. This one is at 2. Left bound, right bound, guess. 3.236. Okay, so now I need my minimum and maximum. So second trace, let's do minimum first, because I'll go right to left. So I'll find this minimum. Left bound, enter, right bound, enter, guess, enter. And this point is 2.732 negative 4. And I'll do the next maximum. So that's choice 4. Left bound, right bound, guess. Oh, 0.99999, that's 1. You should round that appropriately. So I have one more minimum to do. All right, left bound, right bound, guess. Negative 0.732, negative 4. All right, I'm done with you, calculator. X goes to infinity, g of x goes to infinity, x goes to negative infinity, g of x still goes to infinity. Both end behaviors go up. It is an even degree. The intercepts for the x are negative 1.236, 0, 2, and 3.236. The y-intercept is 0. It went through the origin. The intervals on which g decreases and increases. Okay, if I read the graph left to right, I'm only going to use the x coordinates of my maximum and minimum. So we are decreasing on every x less than negative 0.732. Then we're increasing when x is between negative 0.732 and 1. And then decreasing when x is between 1 and 2.732. And then increasing when x is greater than 2.732. For maxes and minimums, I'm only going to list the y value. And this function is neither. Odd would be rotational. 180 degrees rotational symmetry around the origin. It does not have that. Even would be y-axis symmetry. It does not have that, because y-axis symmetry, every point xy has a corresponding negative xy. So even though these y's are the same, these x values are not the same value with a different sign. So it is not even, it is neither. Find all the zeros. I'm going to set each equation equal to 0. A does not factor, so I'm going to use the square root method. So plus or minus 5i, and those are non-real, complex. For b, I'm going to use the square root method again because I have a quantity squared, so I'm going to subtract 16. Square root both sides. Don't forget plus or minus when you square root both sides. So I get negative 3 plus or minus 4i. Also complex. Does C factor? Does anything multiply to negative 10 that adds to negative 3? Would be negative 5 and positive 2. I'm going to set each factor equal to 0. And we get x is 5 and x is negative 2, and those are both real solutions. For D, let's see if I can box method or split the middle. Negative 15, and I want to add to 2. Ooh, I'm going to do 5 and negative 3. For you box method people, oh, I didn't leave myself enough room. That's okay. Wait, that says cubed. I bet it was supposed to be squared. That's a typo. Okay, the only way to get negative 3 is 3 and 1, but this row has to be negative. The only way to get 5x, it's 5x and 1, so this has to be x. So my factors are x plus 1, 5x minus 3. If you are a split the middle, the greatest common factor, and there's your same factors, 5x minus 3 and x plus 1. So setting each factor equal to 0, x equals negative 1, x equals 3/5, and they are real. Does anything multiply to negative 2 that adds to 8? No. Because the middle term is even and the leading coefficient is 1, I'm going to complete the square. So half of 8 squared to both sides. And then, let's see, that is 18. This is x plus 4 squared. I'm going to square root. So I get plus or minus root 18. Subtract the 4. And those are both real solutions. And last but not least on this page, does anything multiply to 30? Sorry, that adds to negative 10. No. But again, since b is even, I'm going to subtract the 30 to the left, complete the square, so half of 10 squared. Half of negative 10 is negative 5, square root both sides. Add this 5. and those are non-real, complex. Last page, yay! A pizza is removed from the oven and allowed to cool on the counter before it is served to the family. That's good, we don't want to burn our mouths. The following function is given. What is the temperature when the pizza is removed from the oven? So that's when T is 0, little t is 0. So you can either figure out the initial value or we can type it in. Let's do some typing. We're gonna do 75 plus 325 e to the negative 0.324 times 0. 400 degrees. If you want to see the E is second ln down here. So big T is 400 degrees Fahrenheit. What will the temperature be after 10 minutes? Round to the nearest thousands. Okay, if I hit second enter, brings back what I just typed, and I can change my 0 to a 10, or you can type it all, and we get the temperature will be 87.728 degrees Fahrenheit. At what time will the temperature be 150 degrees and therefore safe to eat? Well, way before 10 minutes. So let's see. That is when 150 equals 75 plus 325 e to the negative 0.3. I'm going to subtract 75 to the right, left, excuse me. That is 75. Divide by 325. So we get 0.2307 ... is e to the negative 0.324t. I'm going to change it to a log. So ln of 0.2307 ... is negative 0.324t. So ln of my answer. So second negative button is answer. Second negative, see ANS right there. Divided by negative 0.324. So t is 4.5, so 5 minutes, because it says whole number. All right, the last question. The strength of our Wi-Fi signal is measured in decibels, which is dB. Decreases based on the distance away from an access point in meters. The following equation can be used to signal the strength. So what is the strength at the access point? So that is when m is 0. Let's type it in. 10 plus 40 e to the negative 0.2 times 0. That is 50. Decibels, I guess. What is the strength 5 meters away? So that is when we're going to substitute in 5. So second enter, replace the 0 with a 5. Whole number. So that is 25 decibels. How many meters you have to be to have a signal of 15? So 15 equals 10 plus 40 e to the negative 0.2m. So I'm going to subtract 10. Divide by 40. Change it to a log. And divide by negative 0.2. And this says thousandths, so let's do ln of 0.125 divided by negative 0.2. So that is 10.397 meters away. Congratulations, you have finished the video on the progress check review. Print yourself another review and do it again. Make sure you can do the whole thing with no help and no resources before the test.